This is a brief description on how I do a parasitic drain test using a multimeter. A parasitic drain refers to any discharge on the vehicle's battery while the vehicle is left standing, causing the battery to go flat. Before I start, I always like to make sure that the battery is in good condition, fit for doing the test. So to start, I'm going to establish the battery condition. I'm going to use this meter for that. If the battery is found to be bad, you need to rectify that either by charging it or replacing it. So we'll just do this test. In vehicle, automotive, regular flooded, EN 650. Yeah, good battery. Now that I know the battery is good, I like to set the vehicle up ready for doing the test. I always make sure the vehicle is run, then switched off, doors shut or latched so that the car thinks they're shut. Latching the doors means that I can leave the doors open but the vehicle thinks they're shut and it can shut down, and that way I can access any fuse boxes or other components without waking up the vehicle's systems. Some vehicles can take an hour to shut down fully. Now that I've set the vehicle condition, I'm going to connect the multimeter in series with the negative terminal. That's to say, I'm going to place the meter in between the negative cable and the battery terminal. You can do the test on the positive side, but the risk of short circuit carries a great deal more potential for harm to you, the car or your equipment. I always try and access negative. Firstly, I'm going to set the multimeter up ready for amps testing. So I remove the red lead from the voltage and ohms port and place into the amps port. Okay, this is a 10 amp fused circuit. Then I'm going to just switch a meter on, round to amps, okay, and select DC. So I'm ready to test DC amps. Now the important part is to introduce our meter or the test leads into the connection without losing connection at any time. If we lose connection, we run the risk of resetting any potential faults that may have been present, or restarting the whole shutdown time, or worse still, if we caused any sort of sudden interruptions, can result in damage to electronic components. Okay, so we've now disconnected that, but we haven't disconnected the power source. It's now running through the meter. So there you can see the parasitic drain on this vehicle is 22 milliamps, 0.022 amp. I'm always looking for less than 50 milliamps, which is widely sort of seen as an industry standard in my experience, and that's certainly what I'm always looking for, less than 50 milliamps. Just for the purpose of the video, look, I've just opened the door to wake it up. That's waking up the electronic systems, and then we can just see what it does. Look, it's pinged up, it's 1.8 amps, and then we can just wait and see as it clicks down. It's going into a shutdown. It'll do this in several stages. as a note of reference, make sure that you know what your meter's capability is in drawing current, because when I wake that system up, it popped up to about 2 amps. If I had unlocked the door, actuated it, it would have peaked past 10 amps. So know what you're sort of expecting to find, because obviously you could damage your meter. See, it's shut down another stage. And that's pretty well come down to a rest. Okay, so that just leaves one last thing to do. That's to take the meter away, and I will do that again by not interrupting it, because I don't really want to reset anything on this car. Okay, the final thing to do on this is just return the meter, take those leads back out, put over into the voltage port, okay, and switch off, and that way the meter is safe to go and use for volts and ohms and everything else without causing any damage to the meter. Okay, thanks for watching.